Hello everyone, welcome back to my channel. I am A. Purnasheshan, Department of Information Science and Engineering, USN 1VE22IS001. I am student of Sri Venkateswara College of Engineering, Bangalore. Subject Operating System. And today, the main topic of our presentation is disk scheduling algorithms. There are totally 6 disk scheduling algorithms, that is FCFS, SSTF, SCAN, CSCAN, LOOK, and CLOOK. So let us discuss brief one by one. So FCFS is nothing but first come first serve. It follows the algorithm of queue, that is nothing but first in first out. Whatever the request comes first, that will be scheduled first, and then so on. So this is the simplest form of disk scheduling algorithm. This serves the request in the order they are received. This algorithm is fair but do not provide fastest service. It takes no special care to minimize the overall seek time. Example: consider a disk queue with request for input-output to blocks on cylinders, that is 98, 183, 37, 122, 14, 124, 124, 65 and 67. As I told earlier, this is nothing but first come first serve. So whatever the request comes first, that will be scheduled first. So let us take an initial head pointer as 53. So from 53 it will first go to 98, which is the first blocking request. From 98 it will go to 183, and from 183 to 37, and from 37 to 122, 122 to 14, 14 to 124, 124 to 65, and from 65 to 67, and so on. So here you can see the graph of it as follows. So if the disk head is initially at 53, it will first move from 53 to 98, and then to 183, and then to 37, and then to 122, 14, 124, 65 and 67, as I told earlier. So the total head movement is 98 minus 53. So it is nothing but the first scheduled block minus initial head, plus 183 minus 98 plus 37 minus 183, and so on. So the final total head movement will be 640. So this is called FCFS. Now let us see shortest seek time first, that is SSTF algorithm. This selects the request with minimum seek time for the current head position. SSTF chooses the pending request closest to the current head position. That is nothing but it is similar to SJF. So which is the closest block request? It will process that first. Now whereas in FCFS, whatever the block comes first, it will process. But whereas SSTF is same as SJF scheduling. Whatever comes which is very closest to disk process or a disk request, that will be processed. So let us see the graph of it. See, consider a disk queue with request for IO to blocks on cylinders, that is same as before I am using, that is 98, 183, 37, 122, 14, 124, 65 and 67, and I am taking the same old head pointer, that is 53. So from 53 it will go to 65, which is closest to 53, and for 65 the next closest request is 67, and from 67 the next closest request is 37 and not 98, because the 67 minus 98 is 31, whereas 67 minus 37 is 30. So the 37 is closest to 67 than 98. So it will go to 37. And from 37, the next closest request is 14. And from 14 to it will go to 98 and so on. You know how it will go from 98 to 122, 122, 124, 124 to 183. So if the disk head is initially at 53, the closest is a cylinder 65, then 67, then 37 and so on. So it services 37, continuing we service 14, 98, 122, 124 and finally 183. The total head movement is only 236 and the calculation of head movement is same as FCFS. Now next to disk scheduling is nothing but SCAN algorithm. In this disk arm, the disk arm starts moving towards one end, servicing the request as it reaches each cylinder until it gets to other end of the disk. At the other end, the direction of the head movement is reversed and servicing continues. The initial direction is chosen depending upon the direction of the head. So in this types of disk scheduling, it will first go to the end of one point, and from that point it will start scheduling as FCFS. So the end will be left side end. In terms of SCAN, it will go to left end, that is until 0, and from 0 it starts scheduling the right side process. And you can see here, first from 53 as a head pointer, it goes to 37, and from 37 to 14, and from 14 to it touches 0, and from 0 it comes to 98, and from 98 it will go to 122, 122 to 124, 124 to 183, and so on. So this is how SCAN works. scan is nothing but it will scan first all the left side requests and then it comes to right side. So, if the disk head is initial at 53 and if the head is moving towards the outer track, it services 65, 67, 98, 122, 124 and 183 as I told earlier. At cylinder 199, the arm will reverse and will move towards the other end of the disk servicing. The scan is also called as elevator algorithm, and the calculation of head moment still remains the same, and so here the total head moment is 236. And this is even more better than SSTF and FCFS, because as compared to SSTF and FCFS, it has a very less head movement. And next is C-scan. C-scan is nothing but circular scan algorithm. In case of scan, we have traversed until the end of the disk, that is 0. But in case of circular scan, it will come to the right side, whereas scan it goes to the left side. So in C-scan, it will go until the end of the right side disk, that is nothing but 199, and it will come back and it will traverse the rest of the things. So C-scan is a variant of scan designed to provide a more uniform wait time. Like scan and C-scan moves the head from end of the disk to the other servicing the request along the way. When the head reaches the other end, it immediately returns to the beginning of the disk without servicing any request on the return. Example, consider a disk queue with request for I/O to block on cylinders 98, 183, 37, 122, 14, 124, 65 and 67, and head point remains the same 53. In case of scan, we have seen it goes until it traverses all the disk requests at the end at the left side and touches 0. Whereas circular scan, it is the opposite of it. It traverses all the disk requests at the right side of the disk and touches 199 and then comes to the left side. So first from 53 it goes to 65, and from 65 67, from 67 to 98, and from 98 to 122, 122 to 124, 124 to 183, and then it comes back to 14 and 37. So if disk head is initially at 53 and if the head is moving towards the outer track, it services 65, 67, 98, 122, 124 and 183 as I told. At cylinder 199, the arm will reverse and will move immediately towards the other end of the disk. Then changes the direction of head and services 14 and then 37. Note, if the disk head is initial at 53 and if the head is moving towards track 0, it services 37 and 14 first. Whereas at cylinder 0, the arm will reverse and will move immediately towards the other end of the disk servicing 67 and so on. But in terms of C-scan, when it comes to 199, it services first 14 and then it comes to 37, not from 37 to 14. And now let us see Luke scheduling algorithm. Luke is same as scan, but with the difference with the arm goes only as far as the final request in each direction. Then it reverses direction immediately without going all the way to the end of the disk. That is, in terms of scan, it traverses all the disk requests at the end, that is at the left end, and it touches 0. Whereas in Luke, it does not touch 0. It will go until the final block request, which is at the left, that is 14, and then it reverses back to the right side, which are disk requests are present. So this is the only simple difference between scan and look. Example, for same question in the order request service using look will be 53, 37, 14, 65, 67, 98, 122, 124, 183. Here we are not scanning 0. So that is called as look. Thus the total head movement is 208, and this look is even more better than scan because we are not taking 0. It does not the head movement reduces. Look and C-look scheduling are different versions of scan and C-scan respectively. Here the arm goes only as far as the final movement in each direction. Then it reverses without going all the way to the end of the disk. The look and C-look scheduling look for a request before continuing to move in a given direction. Example, consider a disk queue with request of input-output to blocks on cylinders, that is 98, 183, 37, 122, 14 and 124. So, as we have seen scan and C-scan, where scan traverses left side and then reverses, and whereas C-scan goes right side and then reverses. Look is also same. It goes to left side first, that is look, and it doesn't touch 0. It will go until the final request, that is 14, and then it comes to and it will revert to the right side of the disk block request. Whereas C-look is opposite of it. It will go until 183, which is in the right side, and then comes back and traverses the disk schedules requests which are in the left side. So you can see from 53 it goes to 65, and from 65 it goes to 67, 67 to 198, 98 to 122, 122, 124, 124 to 183, and it does not touch 199 because this is C loop and it's not C scan. This is the only difference between C scan and C loop. C scan will even go to 199, but whereas C loop will only go till the final request, that is 183, and from 183 it will come to 14 and then to 37. If the disk head is initialized 53 and if head is moving towards the outer track, it services 65, 67 and so on until 183. At the final request 183, the arm will reverse and will move towards the first request 14 and then serves 37. So these are the various types of disk scheduling and algorithms. I hope you all have understood my explanation. And for more queries and more explanation and for further topics, please comment. Thank you.